Math Man!
Alright students, welcome back to Math Man's Algebra Academy. Today we're looking at Chapter 2, Lesson 2, Checking Solutions of Inequalities. So, when you're checking solutions of inequalities, there's really two methods for answering. You can either insert the number in place of the variable and see if it makes sense, or, especially for the more complicated ones, you can solve the inequality completely and then insert the number for the variable. We'll do a couple examples of each just to show you how to do it. Here we go. Example 1. For each value of w, determine whether it is a solution to w is greater than 13. So first off, we have w is greater than 13. What we want to look at is 13 greater than 13? That's the first option over here. And the answer is no, because 13 can't be greater than 13. Second, we have 19. Is 19 greater than 13? Well, obviously yes, right? How about 9? Is 9 greater than 13? No. And then 15 clearly is greater than 13. Alright, pretty simple, right? Okay, example 2. For each value of u, determine whether its solution to 30 is greater than 5u. Now this one we're going to have to actually do a little bit of work. 30 greater than 5u. Well, we got to put 6 in the place of u. So 30 is greater than 5 times 6, which is 30. Can 30 be greater than 30? Nah. How about 30 greater than 5 times 11? Well, 5 times 11 is 55, so that's also a no. 30 greater than 5 times 3. 5 times 3 is 15, so 30 is greater than 15. And finally, 30 is greater than 5 times 5. That's 25, so 30 is greater than 25. Good job. Alright, so now it's time to look at example 3. For each value of 9, determine whether it's a solution to 6y minus 9 is less than 3. So, for this one, we probably want to solve this all the way out first. So let's take a look at it. First, we're going to have to add 9 to both sides, which gives us 6y is less than 12. Then we're going to have to divide by 6 to get y all by itself. And that gives us y is less than 2. Now we can put the numbers in place of the variable and see what makes sense. So for y is less than 2, let's put negative 7 in the place of y. Negative 7 is less than 2, is that true? Absolutely. Negative 6, that's also less than 2. 7 clearly is not less than 2. And 2 can also not be less than 2. Does that make sense? Awesome. Alright guys, let's look at example number 4 now. Now this is a special one and I saved it to last because I wanted to make sure I made the point clear. For each value of x, determine whether it's a solution to 9 minus 3x less than or equal to 24. So again, we're going to want to solve this one all the way out so we can get a good picture of what we're looking at. So first thing we're going to have to do is subtract 9 from both sides. That's going to leave us with negative 3x is less than or equal to 15. Then we have to divide by the coefficient of the variable, which is negative 3, so that we can get the x all by itself. So it's going to give us x and negative 5, but here's the thing. When you have an inequality, if you multiply or divide by a negative, it flips the sign. So we're going to have x, which is greater than or equal to negative 5. So now that we know that, we have to start putting in the values. So let's put in negative 8 for x. Is negative 8 greater than negative 5? Absolutely not. Is 9 greater than or equal to negative 5? Yes, yes it is. How about negative 5? Is negative 5 greater than or equal to negative 5? Well, negative 5 is not greater than negative 5, but it can be equal, so that will be yes. And then of course we have negative 1 greater than or equal to negative 5. Now I know this one gets confusing because they're both negative, but I'd rather owe somebody $1 than owe them $5, right? So negative 1 is greater than negative 5. All right, students, so now that you've learned how to determine whether a solution is true for an inequality, you're ready to go for the next lesson. So, if you enjoyed this lesson, if it was helpful to you, like the video, subscribe to the channel, and don't forget to leave comments, and keep up with the Algebra Academy. Until next time, keep the math mathin'.